The problem gives you the cost function, the Cx equals 0.00030 and then 1 multiplied by x to the third minus 0.039 x to the second plus 21.7 x plus 110 21.7 x plus 110 and then x is between the value 0 and 180. We're gonna find the minimum marginal cost and then round to the nearest 10, nearest 10, okay, that means the 2 decimal places. The key term that what I said, the minimum, oops, wrong marker. So minimum and also marginal cost. Basically, you are going to find the minimum of this quantity. We don't have the marginal cost yet. We're gonna form the or find the marginal cost. So I'm gonna write step 1. We're gonna find the marginal cost. Which is C prime. Okay. The textbook most of the time they use the notation like MC as marginal cost just to minimize the confusion when you have to find the derivative on top of it. And then step number 2, we're gonna find the critical value or the critical X that minimize the marginal cost. All right. Then the problem asks you to find the minimum value of it. So step number 3, we're gonna evaluate the marginal cost at that value X. Okay, does it make sense as a plan or the format of the procedure here? Yeah. Okay, we're gonna start with number 1 or step 1. We're gonna find the marginal cost. I'm gonna use notation MC, okay? The marginal cost. So the MC, which is the C prime, is a derivative, which is 0.0003 x to the second minus 0.039 times 2, that becomes 78 x plus 21.7. And then from this marginal cost, we got step number 1. And step number 2, we're gonna find the critical value because we're gonna find the minimum value of this function, not the original cost function. So from now on, we just ignore the cost function provided, starting working on the marginal cost. So we're gonna find the critical value. So this is step number 1. Step number 2, we're gonna find the critical value by finding the derivative of the marginal cost. Okay, so the derivative, we're gonna let this derivative to be 0 because this is a polynomial function. So the derivative of the marginal cost equals, so find the derivative using the basic rule, 0.0006 times x minus 0.078. All right, and then let it be 0. And next we're gonna solve for x, which is the critical value. So x equals, add 0.078 both sides and divided by 0.0006. Okay, so Min, could you tell me what number do you get?
You give me a second.
Okay. So we have x equals 130, which is between 0 and 180. So we save this value or we continue to use the same value. Then after we find the critical value for the derivative of the marginal cost, we're gonna replace it into the marginal cost. So step number 3. So the marginal cost at x equals 130, what would that be? So what is the marginal cost? The one that I put the star here, which is 0.0003 multiplied by 130 squared minus 0.078 multiplied by 130 plus 21.7. And then you just put in the calculator and get the number out. All right. Again, could you help me find that number, please? So the value is 1663. Since we round to the nearest cent, so to decimal places. This is the marginal cost. Remember, the marginal cost is the rate of change of the cost per item. So that means the change in value would be $16 per item. Okay, so we claim to be the minimum marginal cost as the answer. And how do we know for sure? We're gonna verify it. Verify using the second derivative test. And the second derivative test said if the second derivative greater than 0,
That's the minimum.
remember concave up, it's gonna be the minimum. If the second derivative is less than 0, concave down, so gonna be the maximum value, okay? So we're gonna keep going with the second derivative of the marginal cost. From what we found, the first derivative is 0.0006x minus 0.078. So then the second derivative would be 0.0006. No x. It's a fixed number. So then for any x, the value of the second derivative always greater than 0. If it is greater than 0, gonna be the case that gonna provide the critical number, gonna provide the minimum value of that quantity. So then the critical number or the critical value x equals 130 gives the minimum marginal cost.
Oh,
And then we are done. So this step is the verifying step. And the answer that we're gonna need is 16.63. So test at, because this is the closed interval. So at x equals 0 and at x equals 180, just to make sure that the left and the right end will not give you higher number or lower number than 16.63. So we go back to the marginal cost function and replace x with a 0. So we're gonna be the marginal cost at x equals 0 equals 0.0003 times 0 squared. This is easier, right? Because we replace x with a 0. So then we get this one gone, we get just 21.7, which is not the lowest. Okay, not the lowest. And then same way, marginal cost at x equals 180. Do the same way, 0.003 multiplied by 180 squared minus 0.078 multiplied by 180, and then plus 21.7, and get in the calculator. The number should not be as low as 16.63.
17.38.
What you get?
17.38.
17.38,
38.
which is still higher than 16.63.
Yeah.
Okay, again, it's not the lowest. So then the winner is the 16.63 or at the critical number. Okay, so I'm gonna add over here because that's what I missed. Evaluate this the value at C, and then the marginal cost at 0, marginal cost at 180, because this is about the closed interval problem, not the open end. So we have to check the left and the right endpoint as well.